In topic 4.2, we are going to review some things that you should have learned in physics last year. So we're going to review it. So the first thing that we're going to take a look at is the notation in calculus for position. We use S of t or x of t for position. V of t for velocity, which is the derivative of position, and then a of t for acceleration, which is the derivative of velocity or the second derivative of position. So position, velocity, acceleration. So that's the notation that you should know for those. Now, when we study motion initially in calculus, we will consider straight line motion. Okay, we're concerned with four things: the position, the velocity, the speed, which is different than velocity, and acceleration, which is different than speed and velocity, which some people realize. So we've already talked about the notation. That is when an object is moving along the x-axis. There are times when it moves along the y-axis. The notation will be y of t. Let's just talk about position. The notation for position, again, we've already said is S of t. So if S of t equals t squared minus 3t minus 3. S of t gives you your position from your starting point right here. So when we plug in 0 into the equation, you end up getting -3. So you are here, initial starting point. When you plug in 1, you'll get -4. So you'll be here, assuming we're talking about seconds. When you plug in 2, plug 2 back into here, 2 squared minus 2 times 2 minus 3, you're back at -3, so you're there after 2 seconds. Plug in 3, 3 squared minus 6 minus 3 gives you 0, so you're here after 3 seconds. Plug in 4, 4 squared minus 8 minus 3, that gives you 5. So you are at this position at t equals 4. So this gives you your position in terms of starting here, not starting here, but in terms of the origin. The number you get, it's not the distance traveled, it's the position you are to the right or to the left. When you get 5 after, it doesn't mean you just traveled 5, it means you're at position 5 to the right. So in essence, we started here, we went here, we went back to here, then to here, and then to here. All of that would be our total distance traveled. So this gives you your net distance. Okay. Let's look at velocity. When an object moves, the position changes over time. So we can say that the velocity function is the change of the position over time. So change in position over time. It's a rate. We know this to be the derivative, and that's why we can say that the velocity is the derivative of position. Position divided by time. So when your velocity is positive, that means that your object is moving to the right. I'm gonna mainly focus on left and right because that's mainly in calculus what we use. So moving to the right when your velocity is positive, moving to the left when your velocity is negative. Your object is stopped when velocity is equal to 0. Speed is different than velocity. Speed does not indicate direction. So speed is the absolute value of velocity. Velocity has direction, speed does not. So the speed of an object must be either positive or zero. Okay? That means you've stopped if your speed is zero. Absolute value of velocity. All right, then we have acceleration. The definition of acceleration is change in velocity over time. This is change in position over time. This is change in velocity over time. So that's why the acceleration is the derivative of velocity or the second derivative of position. So given a position function, we can now determine the velocity and the acceleration of the function. All right, so you guys should be able to answer these if you've had physics. On your cars, you have two devices that change your velocity. What are they? Velocity is the change in position function over time. What changes your velocity? You have your accelerator. And what else? Brake pedal. Both of those devices will change your velocity. For convenience sake, let us define acceleration function like this. Again, when your acceleration is positive, you are accelerating to the right. And when your acceleration is negative, you are accelerating to the left. Acceleration is equal to zero, the velocity is not changing. Velocity is not changing. When your velocity is equal to zero, your object. People get that confused. The velocity is not changing when your acceleration is equal to zero. Velocity. Just because an object's acceleration is zero does not mean the object is stopped. And that's what I just said. Okay, it means the velocity is not changing. So what device on your car will keep the car's acceleration equal to zero? Brake pedal? No. So your cruise control, if you're always going, assuming that it doesn't accelerate like mine does sometimes, if you're going 45 miles an hour, if your cruise control stays at 45, your acceleration would be zero. Okay, also just because you have a positive acceleration does not mean that you are moving to the right. Positive acceleration means you're accelerating to the right. A positive velocity means you're moving to the right. For instance, suppose you are walking to the right. So we're walking to the right, that means our velocity is positive. When all of a sudden a large wind started to blow to the left, that would mean your acceleration is negative. What would occur? If you were walking to the right and the wind blew to the left, so the wind's blowing directly at you, what would happen? Slow down, right? Just like if you threw a ball up in the air. Gravity would slow the ball down. You're throwing the ball up, gravity's pushing the ball down. You would slow down, which would mean your speed would decrease. And that's going to be important. When velocity is positive, acceleration is negative, you're going to be slowing down. Let's take a look at this example. Here's the position function. What's the velocity? Or what's the acceleration? 2. Take the derivative position, get velocity. Take the derivative of velocity, get acceleration. Okay, so let's do all of these for, let's just do all the position ones first. So plug in 0 into your position, plug in 1, plug in 2. So go ahead and stop the video and plug in 0 through 5 into each one of these equations and fill out the table. Okay. If you filled out the table correctly, you would get 2, -4, +4, and 2. -1, -2, +2, 2, -2, 0, 0, 2, 2, 2, 2. When you plug in 4, 2, 4, 4, and 2. And when you plug in 5, you should get 7, 6, 6, and 2. And notice, again, the absolute value of velocity, your speed, the absolute value of velocity is always positive. What does all of that mean? What does this mean? To the left, but this means that you are being pulled to the right. So moving left, this is negative, and this right here means you're being pulled to the right. What do you think is happening? If I'm moving to the left, but I'm being pulled to the right, am I slowing down? I am. My velocity and my acceleration have opposite signs. But this one, same thing? Yep. Moving to the left, being pulled right. How about this one? The particle is stopped. At that moment, the particle is stopped. How about this one? Velocity 2, acceleration 2. So positive, so you're moving to the right, and you're being pulled to the right. So that's going to help speed you up. Same thing, moving to the right, being pulled to the right. Now, know where the particle is on the number line. Well, that's here. So at 0, you're 2 units to the right. So here's where you're at t equals 0. Here at t equals here, t equals 2. You're here. T equals 3. You're back here. T equals 4. And t equals 5. You're back here. Again, this gives you your position relative to 0. Right. This one's 2 units to the left. Your total distance traveled. It tells you your position relative to 0 at that time. Okay. So that's a lot of work. Okay, a lot of work. But what we can do is we can simplify it a little bit. Okay, what did we notice here? When the velocity was positive and the acceleration was positive. Velocity positive, acceleration was positive. We're moving to the right and being pulled to the right. So you've got two positives. That's going to speed. That's what you need to know. Your velocity is positive and your acceleration is negative. Well, we didn't have that, but what do you think? If you are moving to the right and you are being pulled to the left, you're going to slow down. How about when your acceleration, again, we're going to be speeding up, slowing down, constant speed, or stopped? So how about when your acceleration is equal to 0 and your velocity is positive? You're moving to the right at a constant speed. Moving to the left, being pulled to the right, and be down. Moving to the left, being pulled to the left, that's going to speed you up. Moving to the left, acceleration equal to 0. You're going to be moving left at a constant speed. Your velocity is equal to 0. You are stopped, no matter what. Acceleration is equal to 0. You have a constant velocity. Kind of talking right at the okay. Bottom line is that velocity times acceleration greater than 0. If the product of your velocity and acceleration is positive, what will happen? So here we have positive, positive, you're speeding up. Here we have negative, negative, you're speeding up. So you're going to be speeding up, and that's going to be your justification for speeding up. If your velocity times your acceleration is negative, so anytime the product is negative, here we have positive, negative, you're going to be slowing down. And will be a justification you will use in a free response question. All right, so it says to determine intervals where particles are slowing down and speeding up, we will generate a sign chart for velocity, a sign chart for acceleration, and then the third one, which we'll call motion, product of the first two. That's the reason why I was just talking about the product. Determine the intervals where particles traveling on a straight line whose position is defined by S of t are slowing down or speeding up. So this is very important to make sign charts. Again, the sign charts are not graded on an AP test, but I will be looking for them on your test because you need them to help you justify your answer. Now, first of all, your velocity is 3t squared minus 6t. That's your velocity. In order to make a sign chart for velocity, you know when the velocity is equal to 0. So I'm going to factor out the 3t, and I get t minus 2. So t is equal to 0 and 2. That's where your particle is stopped. I'm going to go ahead and make a sign chart for a velocity. You may have done sign charts last year, I think. have t equals 0, and I'll just call this t equals 2. So what is happening? Is your velocity positive or negative? Well, let's check. When t is equal to 1 in our velocity, you end up getting a negative. I don't care what the number is in here, I just care if it's positive or negative. So it's going to be negative. If I plug in a number here, let's say 10, I'm going to get a positive velocity. Here's my sign chart for velocity. Now I'm going to do acceleration. Acceleration is the derivative of velocity, so at 16 minus 6, I want to know when I have a 0 acceleration. So if I factor out the 6, or to set this equal to 0, 6 never equals 0, so t is equal to 1 when your acceleration is equal to 0. So I'm going to do a sign chart for acceleration, and when t is equal to 1, that's when I have 0 acceleration. What happens between 0 and 1? So if I plug in a half, here, I'm going to get a negative acceleration. If I plug in a number over here, this is where I'm moving to the left. This is where I'm moving to the right. This is where I'm decreasing. This is where I'm increasing. My position is decreasing. My position is increasing. Velocity is decreasing. My velocity is increasing. I didn't say that right. My velocity is decreasing because my acceleration is negative. Okay. My velocity is increasing because my acceleration is positive. So this sign tells you what this is doing. This sign tells you what the position is doing. An antiderivative. Antiderivative of acceleration, and position is the antiderivative of velocity. Now we want to know about speeding up or slowing down. So we're going to call this the motion. Okay? So we put all of this together. We have t equals 0 to 1 and 2. So let's look at from 0 to 1. So here it's negative, and here the acceleration is negative. So a negative times a negative is a positive. So that means that your up. How about from 1 to 2? Well, again, your velocity is negative. You're moving to the left, but you're being pulled to the right. So you're going to be slowing down. Okay? And then here, when t is greater than 2, you're moving to the right and you're being pulled to the right. So you're going to be speeding up. So it says what intervals? Well, in calculus, we use interval notation. So we can go ahead, I'll write the answer here to answer the question. Slowing down. Our interval is going to be from here to here. So we're going to say slowing down. And then the interval for speeding up is from 0 to 1 and from 2 to infinity. Speeding up and slowing down, we are going to use parentheses. We're not going to use brackets because at 1 and at 2, you have to stop. You don't want to include them, so we're going to use parentheses. At example number 4, Some students are frequently asked to find the time intervals when the particle is speeding up and down, and also asked to justify their answers. Sign charts are not scored as justifications by the readers. Instead, the readers are looking for an answer in sentence form. They are easy to construct with justification, written a bit more formally, and reference the comparison and AFT over an interval. Okay, so a particle is moving along a horizontal line with position, S of t, do an analysis of the motion, speeding up or slowing down, and position. This on your own. Next, and then you can check the answers on the website. Then you will also do this one, example number 5, on your own. This again should be familiar to you. You're going to need a calculator to answer all of these questions. And example number 6 is your position function. I have given you the tables, so I saved you time of plugging them into the calculator. These are the values when the position is positive, when the velocity is positive or negative, the position is positive or negative. So I'm saving you time here. Your homework is going to be, part of your homework is going to be to finish the notes and then check your answers on the web.